In this video, we're going to be covering Lab 8, which is about forensics, and in particular, we're going to be looking at memory forensics. So in the lab sheets, there's some information about memory forensics, including how you would actually take a memory snapshot using various software packages for Windows, Linux, and Mac. And then we look at how you would analyze those dumps once you've obtained them. We are going to use a program called Volatility, and we're going to use Volatility 2.6. That actually needs to know a specific version of the operating system of the memory dump, and we'll show you how to do that. Volatility 3 does that for you, but it lacks certain features that made this lab more difficult, so that's why we're using. So in the lab sheet, it tells us to run the container volatility. So let's just do that. Copy the command and run it. And it's asked us to change directory into /opt/memory. And if we look at that, we have a memory dump file, which is called challenge.raw. There's another file that we'll use later. But what we want to do first of all is run this. This will actually tell us, so this is volatility. We pass it in the file of the memory dump, and then we're going to run the command image info. We need to do that to find which image we're going to use for subsequent commands in volatility. So this is now returned, and it's given us some profiles that we can use, which are based on Windows 7 service packs, and we can use any of those, and with some additional information. It does actually look at some kernel information about what libraries are loaded to determine that. In the lab documentation, there is a further thing that you can run, which gives us another opinion, which gives us Windows XP S Service Pack 2, but actually we don't have that profile loaded. We have Windows 7, and that will work just fine. So we're going to stick with that. So a forensic analyst looking at a memory dump would look at active processes, commands that were executed, hidden processes if any, and things like browser history. So we're going to look at the processes. So we will copy this command and put that in and paste that. And what we've got here is again volatility with the memory dump file. We pass it in the profile that we're going to use, which is sp1x86, and then we're going to run the command pslist. So this will go through the memory, and it will give us an output of all of the processes that we're running on this file, which are shown in the lab sheet here. And normally you would go through this to see if there's anything unusual that's been running or anything that would give you an idea of what was going on at the time. You can see, for example, there's a process here, dumpit.exe, and that is the process that was running to actually create the dump. We can see that there was a command line that was running as well, and that also gives us something to look at. So there's a number of processes that we can look at. So command.exe, which is the process responsible for the command prompt, and we may be able to see what commands were being run. Dumpit is the process, as I said, that produced the memory dump, and Explorer, which is the process which handles the file explorer. Now, since we've got the command.exe, we can do a command scan. So we'll copy the file for that and run that. And we can see that some information about what was actually run on the command line. And for example, here's one which is a Python file, Python program that was run, where it was run on the Hello Users desktop, and there was a file called debian.py.txt, and that was sort of interesting. Now we can check if the Python script sent any output to standard out. For this we can use the consoles plugin. So let's see what happened when that person ran that file. And what we can see from this, if we go through it, let's go back up to where it was run, which is here, and it gives you some information of what's run, and we can see that when this was run here, it produced some output there. And that's been written to standard out. What we've sort of indicated is that when you do a hex to ASCII converter online, it produces rubbish, and so we're inferring that it's likely to be encrypted, but we'll leave that for now and just sort of come back to it later. Another thing that we can look at is the environment variables. And these sometimes gives you some interesting information, so let's have a look at what environment variables there were. Oops. Yeah, so there's an awful lot of them, and what we look at is that we're mainly interested in environment variables for the command exe that was running the Python file. And if you look at the environment variables, there is one called Thanos, which has the text which says XOR and password. So this is a little bit contrived, but let's just do that again, but we'll pipe that to a grep command and put -i Thanos and see what that gives us. So that will strip away everything other than where it mentions Thanos. And you can see that these are the environment variables for each of these processes, including the one that we're interested in, which is the command.exe. And the environment variable is set to XOR and password. So basically, that's sort of suggesting that the encrypted text that we've got may be an XOR encrypted text, and we can brute force the characters of that using CyberChef. So if we do that, we can convert it. We first convert from hex, which converts the characters to ASCII, and then the second is an XOR brute force, and we can successfully try the numbers from 1 to 100 and XOR them. We see that the second entry is this, and which is actually part of the flag. So we've given you that there. If you really want, we can try that. Let's go into CyberChef. And what we go is go back to the lab and get the hex. From hex. And then XOR brute force. We'll leave everything as standard, so the key length is 1, sample length is 100, and you can see that it doesn't take very long. It's basically key number 2 is the decrypted flag. So that was relatively easy. So we've got that part now. Now we're going to do something else. We can look at extracting password hashes from accounts. And so we're going to use volatility to do that. And so we will use this, which is hash dump. And this will look in a set of specific places, especially that Windows sort of uses to store password hashes. And let's run that, and that will give us the password hashes. So the one that we're interested in, there's a series of them, but we're going to look at hello, and it gives you this password hash. So it's hello, we don't need to worry about that number, and we just copy that, and we're going to put that into a file called hash.txt. Paste that in, escape, right, quit, and we're going to run John. And this is John the Ripper, which is a program that's specifically for cracking passwords. And what that takes is that it's saying that the format is going to be NT, because we know that it's an NTLM hash, and that's the type that one of the types that Windows uses. We're going to pass it in a word list of suggested passwords that it's going to check in. Now, I've cheated slightly. That passwords has the password in it, but this depends on people reusing or using the basic same passwords as everybody else. We'll put the output into what's called a pot file, and we pass it in the hash file. So we can hit return, and it comes back with flag, you are good, but. So I'm going to, so it comes back with a flag, which I will blur out, but you combine that with the bit of the flag that, oh no, it's there anyway. So we can concatenate that flag. So John gives us some output, and including the flag, it's decrypted. And in fact, if you look at the passwords.txt file, it has a whole series of 12 passwords, including the one that we're looking for. So all it does is go through and hashes very quickly the thing in all of these, and compares it with the hash in that the file, and it sort of comes back. And so you just combine those two, and you've got the flag. And that is it for Lab 8.